Question 1.4 has two parts. A is explain the meaning of this statement, electric charge of a body is quantized. And B is why can one ignore quantization of electric charge when dealing with macroscopic, that is large scale charges. Let us answer the questions one by one. A is explain the meaning of the statement, electric charge of a body is quantized. So we will write the statement, electric charge of a body is quantized. We can write the word quantized comes from the word quanta or quantum. That simply means discrete, indivisible, or fundamental unit. The meaning of this statement, electric charge of a body is quantized, means electric charge on a body is the multiple of a unit charge. And we can write total charge on a body Q is equal to integral multiple of a unit charge E. And the value of E is the charge on an electron, that is 1.6 into 10 to the power minus 19 coulomb. So all the charges in the universe comes as a multiple of a small packet of charge, that is the charge on the electron. And any charge is always a multiple of that unit charge E. And this is called the quantization of charge. We can also add one line that fundamentally charge is not continuous. Let us answer the question B now, that is why can one ignore quantization of electric charge when dealing with macroscopic, that is large scale charges. We can answer it as charges in the universe always come in multiple of discrete packets, that is Q is equal to N multiplied by E. The value of E is equal to 1.6 into 10 to the power minus 19 coulomb, a very small value. So we can say the charge on one quanta or one electron, one unit, is 1.6 into 10 to the power minus 19 coulomb. This quantity is too small, and when we deal with large scale charges on a body, suppose 1 microcoulomb or 1 coulomb, the number of those units or the number of quanta can be found by dividing the charge by the small amount of charge, that is the unit charge E. And even for a microcoulomb quantity of charge, that is 1 microcoulomb, and when we try to find the value of N, we have to substitute all the values. And what do we see? 1 microcoulomb is 1 into 10 to the power minus 6 coulomb divided by 1.6 into 10 to the power minus 19 coulomb. And the value for N comes 6.25 into 10 to the power 12. So the value of N is huge. It is billions of trillions. So even for a microcoulomb charge, the number of unit charges that has to be multiplied or put together is billions of trillions. It is 6.25 into 10 to the power 12 such unit charges combined to form that 1 microcoulomb charge. And because of this huge number of small quanta, we ignore that the charge is quantized, and we say that okay, charge is continuous. It is something like in a glass of water, we know that water is made up of small molecules of water. So the molecules of water are the discrete entities. But if we consider that, then it becomes very tough to imagine how many numbers of molecules are there in a glass of water. So we ignore that numbers of molecules of water, and we say that water is continuous. It is like a flow. In the same way, for macroscopic level, we say that charge is like a flow, charge is continuous, and it is not quantized. But fundamentally, charge is quantized. Just add one more line to your answer. You can say, since the number of unit charge entities are much bigger number, so we ignore the quantization and consider charge is continuous.